This video is sent by Y Combinator 12 days ago. It's an ad. It's an ad by a startup company, and they want to launch AI data centers into space. And I think it's a bad idea. I'm a hater. I think the thermodynamics don't work out. I think it doesn't make any sense, and I think it is completely like tech bro hype. They don't understand space. All they hear is like, ooh, space is cool. Space, cool thing, plus AI, another like cool hype thing. It's gonna go well, right? Boom, $1 trillion company. Well, you know what? Space don't care. Space don't care about that, and space doesn't work like that. So, anyway, we're gonna do this. I'm gonna do it. I haven't watched this video. I've had 5 different people send this to me and being like, hey Karbon, what do you think? I've had coworkers be like, hey Karbon, I know you work on like you know all the tech stuff and you work in like space launches and stuff like that. Like, well, what do you think about this? And I'm like, okay, fine. I'm already getting heated. Okay, let's do it.
This moment right here
Starcloud 1, separation confirmed.
could represent the birth of an entirely new industry, data centers in space.
The problem is that data centers take up a ton of space and they need a huge amount of energy. Enter Starcloud.
This is the beginning of a future where most new data centers are being built in space.
They're starting small, but the goal is to build massive orbital data centers that will make
Okay, I'm already gonna say it. I'm already gonna say it. This would be great if it worked. Okay, I think it would be amazing if we could get stinky data centers that pollute the Earth off of the Earth and into space. That would be cool, but I don't think the physics work. So let's see, do they have a solution? The main things I'm looking for is, how are they getting their energy, right? Like, are they really just going to rely on a gigantic fucking solar panel and hope for the best? And also, how are they going to handle radiation, which is, shocker, the Earth has an atmosphere and protects us from the deadly laser that is the sun. It's going to blast everything that's in orbit. You have a ton of radiation. And also, how are they going to cool the systems? Because there's no air for conductive and convection heat dissipation. How are you going to cool your freaking GPUs that get super hot, right? Well, and also like memory storage and stuff like that. Like, how are they going to do it? So let's see.
computing more efficient
Okay.
and less of a burden on the limited resources down here on Earth.
I can see why it seems like a long shot to some people. To me though, the reason for doing this is that the potential impact is absolutely massive. So even if you think there's a small percentage chance of it working, then it's worth taking this kind of risk.
That's bait. That line there is venture capital bait. You know what you know how you want to raise $1 billion from a tech startup? Here, let me tell you. You say there's a 1% chance of this is going to work, but if it works, it'll be game changing. The world will change forever and you'll be filthy rich. That's what venture capitalists get horny on, okay? That's what they like to hear. That gives them a hard on. They write you a check for like $1 million, okay? That's like the whole focus is moonshot projects that, if work, will pay off massively. If you want like a stable business that will double your money, venture capitalists don't care about that. They are not interested. They want a 1% chance of 10,000 Xing their money. If you think you're a gambler in Vegas, you haven't met Silicon Valley tech bros, okay? It is like they want the biggest gamble possible. Just that's what we're dealing with here. Okay. Ooh. Okay, it is hard tech.
Philip Johnston and his team at Starcloud recently made aerospace history when they launched a satellite into orbit carrying an NVIDIA H100 GPU.
This is the
Is that
first time
history?
anybody's tried to launch data center grade terrestrial Earth-based GPUs into space. It's going to be the first of many.
While it's essentially
I mean, is that an achievement? You just like put a GPU inside a box and then had SpaceX launch it for you. Okay, maybe let's
a
see.
prototype. It's still 100 times more powerful than any computer that's ever operated in the vacuum of space.
I mean,
To find out how
that's
they
true.
went from an idea to launching a demo satellite in less than 2 years, we visited Starcloud's HQ in Redmond, Washington. Tell us about what Starcloud is working on.
We are building data centers in space, initially to provide GPU compute to other satellites, and then later to compete on energy cost, even with terrestrial data centers.
Starcloud's goal is to build the world's first orbital data centers.
Okay, there's actually some compute costs that do happen in space. Like right now, what we have mostly is there's like little lasers, but there's like a laser mesh network between a bunch of satellites in space. And then they combine all this laser streams of data into one big laser stream and then beam it to an antenna on Earth. And then that antenna on Earth then does the calculation and beams back up stuff. If you could do compute in space, that would be cooler. It would save the communication delay. Like you wouldn't have to route stuff right now. Because surprisingly, like your internet modems, they do a lot of routing and computation inside of them. And if you could have that computational load done in space, it would make your connections faster. Like you would be able to do all the pathfinding algorithms to find out like which is the fastest satellite hop to get to this certain person. That sort of math being done in space is helpful. That is like a helpful thing. So yeah, I mean, but you don't need that much. Like you don't need that much compute. At the end of the day, they're sending up stuff for a computer modem.
Massive GPU clusters powered by constant solar energy to run AI compute at scale. Operating in a sun-synchronous orbit, they'll draw uninterrupted sunlight for energy, radiate heat into deep space, and run with zero fresh water and much lower carbon emissions than data centers down here on Earth. By taking the cloud off Earth.
They're saying that they don't pollute. Wait, I need to hear that again.
Draw uninterrupted sunlight for energy, radiate heat.
Oh, okay, so they're getting their energy from a giant solar panel. I knew it. You know that solar panel is going to be freaking massive, right? To power one GPU, I'm pretty sure they need a solar panel twice the size of a football field. Like, it's going to be gigantic. Okay, actually, don't quote me on the energy costs. You know what? Okay, that's an extreme. That's extreme. I overblew it. But they're going to have a huge solar panel, and they need to have those solar panels work for a long time.
Into deep space and run with zero fresh water and much lower carbon emissions than data centers down here on Earth. By taking the cloud off Earth, Starcloud can scale almost indefinitely, free from land, grid, and cooling limitations.
I like how they didn't say free from local laws. I like how they've really like didn't mention that. Now that I think about it, I think the main advantage here is that you can skirt all national laws by essentially having your data center be in international waters, right? Like it's technically a lawless wasteland, so you could put whatever you want in space. Like you could put pirated content, you could put illegal stuff. Oh my gosh. Ooh. Sorry, my brain. I'm evil machinating right now.
And ultimately compete with the cost of the largest terrestrial data centers. Tell us more about how far along you are.
We started about a year and a half ago. We've designed, built, and tested our first satellite, and that.
Okay, that's pretty good. Okay, actually, I got to give it to them. If they started a year and a half ago and launched a satellite, that's impressive. That's really impressive.
That will be the first satellite that will have an H100 from NVIDIA on board. The purpose of this is really to prove that our thermal management and radiation.
Oh, and they're doing it properly too. So they. Is that exposed skin? Why? Why? Okay. Well, you know, it's fine. It's fine. Maybe it's a lower grade clean room. Okay? Maybe. Okay. So here's the thing. Here's the. I'm getting angry. I'm getting like Karbon chill. Satellite assembly is a very, very careful progress. Okay, it's something that you need to be careful of because all these electronics are very sensitive. They are made for the vacuum of space. All right? Satellites, whoop-de-doo, are made for space, not for Earth. Meaning when you are interacting with it in a dust environment with like things like your skin and your hair everywhere, you can cause problems. You can cause like even something as little as a grease smudge on one of the panels can change the physics of the satellite. Okay? So I don't know, maybe it's just a little sloppy. It's not the end of the world. Maybe this is like a later stage thing and all the sensitive components have already been put away, but you know, it's fine. And I do see he's not wearing a watch. He's wearing a wrist strap, so he is grounded, which is good. He's grounding himself. That's fine. Okay.
Shielding techniques allow us to operate the state of the art in space. We're going to be running a whole bunch of demonstration workloads on that. We'll be the first to run Gemini.
Also slight mention. Every space company has a giant American flag. Actually, they have the smallest American flag that I've ever seen at a space company. Okay. Usually it's the entire wall minimum. Yeah, it's just a slight thing. You're not a real space company unless you have a huge ass American flag if you're based in America. I don't know why. I don't make the rules. It's just something that everyone does.
To run Gemini from Google on there. We'll be the first to do fine-tuning of model and training a model in space.
Why data centers in space? It seems like people are still struggling to get the compute that we need here, building them on Earth. Like, why is space going to be the next frontier for that?
Yeah, so we see a world where almost all data centers, anything that doesn't require very low latency, is operating in space, surely because of the constraints we're facing on energy terrestrially. And
that's fucking cap! We do not have an energy crisis here on Earth. Everyone always says we don't have enough energy on Earth. We have plenty of energy. It's just people are wasting a lot of it. Like, we produce so much energy that is not being used efficiently. Like, there is so much energy waste in our grid system, in how we power and cool things. Freaking, what is it? We have droughts in certain states when most of the water in America right now is being used to water lawns. Most of water in America is being used to water lawns and not crops. I think it's a resource allocation problem, not we don't have enough energy. And if it's really a big problem for you, fucking just post up next to a dam or something, you know? Like, I don't think energy consumption is really that big of a problem. And are you really, is trading space solar panels for rocket fuel launch costs really a better use of environmental impact? Like, if I looked at the environmental impact of a space like Falcon 9 SpaceX rocket compared to, just using some hydroelectricity, like which is gonna be worse? Because these things don't just teleport to space. You gotta build an entire ass rocket. You have to consume rocket fuel and send it up there. And not only once you send it up there, like you have to keep it maintained up there. You're still sending jet fuel up there. And I still am doubtful of like their longevity. Like, how long will they be able to survive in space before they get bolted by random debris or get bricked? Like, unlike a data center that can get fixed and replaced, once you send something up to space, it's there. It's there permanently. Ask any data center technician or engineer how often they have to go to the data center to replace one of their GPUs or hard drives. And then just remember, once you send it to space, there's no takesy-backsies. If it ever fails, it's donezo. Like, permanently, that entire multi-million-dollar satellite down the drain. So it's like, they get bricked all the time. Yeah, you may not notice it, but your GPU, your hard drives, they fail. If you've ever had a hard drive fail on you, you know how catastrophic it is. And that rate of failure is 100 times higher in space. Because you're in space, you're dealing with vacuum constraints and you're dealing with radiation. It is significantly higher that you get exposed to things like solar flares, different velocity movements. Like, sometimes you have to go through sudden accelerations and rotations. You might even get exposed to random debris just bursting in and hitting your satellite as well. So hardware breaks, very common. People are struggling and starving. Have you seen how pretty some houses look? You're so right. Okay, I will say some houses are pretty. You know what it reminds me of? You know what this reminds me? It reminds me of Dune. I'm gonna do a slight detour here. Where's the? Give me a second. Give me a second. Give me a second. I'm pulling it up. I'm pulling it up. Have you seen this? Have you seen this scene from Dune? The like plant scene? This is what this reminds me of. Where it's like, okay, context for people who've never watched Dune. They are in a desert. There is a drought. It's a sand planet. Everyone here needs water desperately. They need water desperately to survive. And to showcase the power of this royal house, they have tropical planets, not tropical planets, tropical trees posted up in their front lawn. Each of these trees takes the water worth of 100 men every day, and they water them. So it's just like the rich people watering these plants, knowing that could be used to feed 100 people each. It's symbolism in the movie. Very good symbolism, by the way. But yeah, sometimes I see stuff like this. I'm like, God damn, resource allocation problems. Anyway, okay, I'm going back. Sorry, I have a hate boner today.
So we're building with a vision to build extremely large, full 40 megawatt data centers. It's about 100 tons. It's what you can fit in one full Starship Halo Bay.
And if this works, what does the world look like?
It takes a huge burden off the grid on Earth, both the grid and the water supply. The way that data centers on Earth keep cool is essentially they evaporate lots of fresh water. This is actually causing huge problems in certain parts of the US where they're just sucking the rivers and the lakes dry in order to keep these data centers cool.
Okay, that's actually a real problem. That is a real problem where water evaporation is the main use of cooling, and they are sucking some lakes dry. I mean, I think we should have laws to reduce consumption, but yes, it is a problem.
Our data centers in space require zero fresh water. Instead of being this evaporation process, our heat sink is infrared radiation into deep space. And so we're building these very large radiators that...
I see. Because there's no air to take away heat, what they're trying to do is they're trying to build a gigantic tin foil heat radiator. I don't know if you've ever seen a CPU. Let me, like a CPU fan. Let me pull it up. CPU fan. Let me show you what they look like so that you can like kind of take a look and see. Here we go. Oh, let me see. Okay. You see like the metal fins on some of these fans? They can radiate heat. So in like space companies, what they'll do is they'll have the same thing where in space you can have heat radiating out of the metal. And what's really happening is you're getting photons leaving the metal. You're exciting electrons and photons are leaving. And as a photon leaves, it cools down the metal slightly. It's an extremely slow process. Extremely slow. Yeah. Are they gonna microwave us eventually? No. This is just getting the heat away through light emission. It's called radiative heat cooling. It's just very, very slow, extremely slow, and they need a lot of it. Like I would say of their satellite constellation, I'd say 90% of their structure is going to be just trying to cool the system. The solar panel itself probably won't even be that big. It's most likely going to be cooling from the GPU and whatever storage device they use. I don't know. We'll see how they do it.
We run a fluid through, but doesn't go anywhere, and then that dissipates heat out into the vacuum of space.
What led you to ultimately starting Starcloud and being co-founder here?
We're seeing an absolute tidal wave of demand for energy, primarily for data centers, but also broadly electrification within our society. And in the Western world, we're not that good at building large infrastructure projects quickly.
Our vision is to put larger and larger satellites in space and prove that this concept works. We can put essentially high compute devices in space that are going to help our customers.
If it works, when it works, it will have just such a huge impact on the world, on the development of AI, the way we train and use AI. So this is,
I don't know how I feel about this. Okay, I see it's technically possible. I see that there's a path to actually being built. Okay, they're not crazy in that I used to think that they were crazy, but now having seen this, I'm actually like, okay, if you build a satellite with a large enough radiator to get rid of the heat, it could technically work. But the cost to actually launch a gigantic hunk of metal in space that could cool your system fast enough, I just don't think it's feasible. Like, it does not seem economically reasonable. And can you, like, have we come to the point where our energy problems and like operations here on Earth are so bureaucratic and complex that we would rather just send stuff into space than fix like hydro dams and nuclear power here on Earth? Like, that just feels like a cop out to me, but okay.
Yeah, one of the most impactful things that I think I could be spending my time on, and that's why we're dedicating so much to it.
Oh, they have a section for skeptics.
This ambitious vision hasn't convinced everyone.
Yeah.
The concept of data centers in space has raised eyebrows and sparked plenty of heated debate online.
I want you to react to Andrew McCallop's viral post. I was wondering if there were any key points in here that you think were easily debunked.
The criticism usually is, in order to dissipate that heat, you need a large surface area, and they think for some reason that that's super impractical.
It is, because you need a huge surface area. Like, are you sending up gigantic chunks of metal into space? Like, you remember, you're putting those things in rockets.
My co-founder Ezra has a PhD in engineering, spent 10 years designing and building large deployable structures, solar panels and radiators. You just have to build a large surface area, and that's what we're doing. So half our engineering team is building a very large, low-cost.
He said just, like it's easy. Okay, these things fail all the time. I want you to know, like, deployable, foldable satellites are only a more recent invention. Like in the past 20 years, deployable satellites they have multi-folding stages, but only a handful. Like maybe 2 or 3 folding stages, nothing more. What they're talking about is something like a 20 plus unfolding wing. Like, you need to fill an entire football field of surface area, and it has to roll out like a carpet in space.
And low mass deployable radiator. So that is the core IP of our company.
Is it fuel for motivation for you now?
Oh, 100%.
You guys are trying to pull off a very difficult business here and a very difficult idea that hasn't been done before.
Yeah, I mean, I have to say I was very inspired by a talk that Sam Altman gave about maybe 8 or 9 years ago.
Oh, he's sucking Sam Altman's dick. I'm not surprised. Okay.
And he said something like, it's easier to build a hard company than it is to build an easy company. There's one hard thing, which is, can we operate data centers in space cheaply? If we can do that, everything else is easier. Hiring amazing people is easier. Getting people to write about us is easier. Even fundraising is easier. It's an unintuitive fact.
Yeah, it seems like you are opting for the path that has very high technical risk, that you can pull this off. But if you can pull it off, people will want it. It'll be incredibly valuable. There's very little market risk. All these other factors.
It's easier to build a hard company than an easy company. Okay. That's he brushed through that. I kind of agree. So it's much easier to say, hey, I'm going to solve cancer, or I'm going to solve like this crazy space problem, right? I'm going to make reusable rockets or something like that. Because it's easier to build a team around that, because good talent will be inspired and rally behind you. It's easier to get headlines. It's easier to just get attention and have people passionate about your work. Whereas if you're like, I'm going to improve supply lines by 3%, no one really cares, and you have to pay people a lot of money to care. In fact, that's probably why most software engineers today get paid a lot of money, is because they're working on like changing a button color or abstracting some API away, and no one gives a shit about it. And so you have to pay them a lot of money to work on something, even though they have really high technical skill to do something else. So what for me, for example, because I work with space stuff and I love doing my little space station work, I take a significant pay cut just because I think the problem is hard and it's fun. And so if you're building a company, or you're like trying to work on something and you want to work on something interesting, it's actually easier to assemble a team around that. It's counterintuitive, right? It's kind of weird. So he's kind of right there. He's kind of right there.
Kind of go away. Taking a step back, you have a pretty uncommon background to start a company like Starcloud.
Yeah, that's true. So I don't come from a space
Did he just say he's
background.
unqualified?
Actually, I started my career as an engineer.
Did this interviewer just say, yeah, you're unqualified. Why are you starting this?
For the first 5 years on the software side, and then before that I studied applied math and theoretical physics, undergrad and masters.
And what ignited your passion to start something in space?
Wait, this guy has theoretical physics and math background and also did software engineering? How's he underqualified? This guy seems qualified enough. What?
I've been passionate about space since I was a kid, but I think what made me realize that there is an opportunity here is seeing how quickly the launch cost is coming down.
That's in part thanks to companies like Space.
Okay, maybe it's because he didn't like get his PhD in space physics, I guess.
SpaceX and startups like Stokespace that are building reusable rockets.
The launch capacity might...
What? There's a startup trying to build reusable rockets that's not Blue Origin or SpaceX? Really? I've never heard of them before. Huh? I did not know this. Well, I hope they're in for a world of hurt. Reusable rockets are really fucking hard. They're really expensive, take a lot of engineering effort.
That are building reusable rockets.
The launch capacity might go up by 100 or 1,000x because you can refly these things every day and because they're producing so many of them. And that enables many different business use cases.
And how did you come up with the idea for Starcloud?
We were initially looking at space-based solar, which is this concept of very large solar panels.
Rockets kind of hot. Okay, I will say reusable rockets are really cool. I think that they're awesome because they really reduce satellite costs and they make things possible that wouldn't be possible before. I'm really looking forward to the new International Space Station or whatever space station America decides to build, because it'll be in an era where we have really cheap reusable rockets, so we can build a crazy new space station up there if it gets approval. But anyway, it is a really exciting tech. Like, I'm glad that they exist and it's been proven possible.
And how did you come up with the idea for Starcloud?
We were initially looking at space-based solar, which is this concept of very large solar panels in space and beaming the power down.
They showed the unfolding. This is what I'm talking about with like the folding structure for the satellite. So you see how like the solar panel
we were initially
wings
looking at space-based solar, which is this concept of very...
You see how they fold out? Usually what this is each one of these junctions here is a spring. There's springs attached to each solar panel, and then there's twine that wraps it all up. So they wrap the whole satellite under tension with some twine, and then when the twine breaks, the springs unfurl them, right? And how they make the twine break is it burns up in space. So when they go up into space, they let the twine burn and then the whole thing unfolds. That's like the whole thing. Like, that's just strat. It's failed a couple times. Like, sometimes the twine doesn't burn and then it crashes into others satellites and doesn't flow properly. Other times it unfurls too early. But I mean, that's the general engineering strat. Now you know how foldable solar panels work.
Very large solar panels in space and beaming the power down.
We ran the numbers on that,
and we wanted to know what is the launch cost where that business model makes sense. The number we came to is around $50 a kilo, where that would break even.
That's a long way from where launch costs are today.
In order to break even, they need launch costs to be $50 a kilo, and today it's $5,000 a kilo? Holy, ambitious. Holy, okay. Damn.
So they pivoted to a different idea.
Big problem with space-based solar is you lose 95% of the energy transmitting it from space to Earth.
So, what if instead of sending the power down to Earth, you sent the data centers up?
So after we reran those calculations, we came to a launch cost of $500 a kilo break even. We're much closer to that today than we are to $50 a kilo. And so that was then the basis of a white paper.
In the summer of 2024, Philip and his co-founders pitched the idea to YC. They got in on what was their third attempt. Back then, they were called Lumen Orbit.
We're building a constellation of orbital data processing satellites to serve other satellites.
What were you focused on primarily during the batch, and how did that kind of shape the company?
We were applying only for the first part of the business, which is providing cloud services to other satellites. We knew, and actually we had mentioned it in the interview, that there was this much larger potential business model behind it, which is providing energy for almost all data centers. But we hadn't really been vocal about that, and we were kind of a bit, maybe even embarrassed to talk about such a grand vision. I think YC just really encouraged us to go for it.
Why was it embarrassing for you to talk about such a grand vision?
I mean, when you tell people that within 10 years, it could be the case that most new data centers are being built in space, that sounds wacky to a lot of people, but not to YC.
In just under 2 years, they were able to build the first demo satellite, the one that's currently in orbit over our heads.
I wonder if they built it or if they paid an existing space company to do it for them. I know there are a few places in that area in Washington that manufacture custom satellites for people, and I have a sneaking suspicion that if I looked at their actual engineering effort, I think they just bought a satellite like not bought a satellite, but like paid for someone to build it for them. I'm pretty sure, probably paid. Yeah, I kind of agree.
Right now. It seemed like you all have very complementary backgrounds that are perfect for this type of company.
My co-founder, Adi, was 20 years on building data centers with Microsoft, and then he was with SpaceX as a principal software engineer. And so he's doing everything on the software side and with the compute module and making these chips work in a high radiation environment. And then my co-founder, Ezra.
Oh, so they did adjust the chips to handle the high radiation. Okay. I don't know if a software engineer and a person who works in data centers knows about radiation and the physics of it, but sure, maybe he studied up. I don't know, it's possible.
Ezra, who's our CTO, spent a decade designing satellites. He worked on NASA's Lunar Pathfinder mission, did the deployable solar panels.
Okay, that's pretty cool. Oh, they're testing in-house. Oh, that's cool. This is called the vibe machine. Hell yeah, ladies, watch out. All your parts get put on here and then it shakes. It's vibe testing for environmental it's vibe testing for rocket launch conditions. So when a rocket like takes off, it shakes, it vibrates, and as it vibrates, it can actually unscrew parts. And so what they're testing here is they're testing the vibration profile of the rocket that they're going to use to make sure that vibration profile does not destroy any of the components on board. It's pretty cool. So the fact that they have one here is a good indicator, but I am noticing it's only in one axis. So they're kind of fucking losers. It's not even 2D oscillation. You should have a 3D oscillation.
Engineering. And
yeah,
so
it's just going up and down. Kind of mid.
So between us, we've got commercial, compute payload, the bit we're doing, and satellite structure. So actually, yeah, the team is extremely well complemented.
Okay, are they going to show me any other stuff? They have a random welding shot. I don't know what this is. I don't know what this is supposed to be. Also, where's your thermal testing chambers? I haven't seen a vacuum chamber in this whole shot. Like, they haven't shown me a single vacuum chamber. I probably know too much about this. They probably didn't expect someone with space experience to look at this. Okay.
We are headed into the main assembly facility that we have. This is where we're extending our deployables and iterating on different prototypes. This is where the engineering team sits. This is electrical and software, and then mechanical engineers back here. This is the cleaner area of the two. If that was...
You're telling me their desks are this clean? And look at these guys, these guys are all pretending to work. I love that they're just pretending to work. It's really funny to me. But it does look clean, and there's only a few exposed extension cables,
Engineers back here. This is the cleaner area of the two. If that was the clean side, then this is what you can think of as the dirty side, where we're fabricating all sorts of aluminum parts for the spacecraft.
And so you're building a lot of the parts and assembling things right here in this facility.
Exactly. So we're
Are you really?
Building all of the payload, all of the power, and then all of the thermal dissipation. Here we have the vibration table, which Ezra's setting up for a vibration test of some of the electrical hardware. So this is where we shake the satellite in all different directions.
Only one direction. They could only afford a vertical Z vibration table. They don't have XY movement. But I mean, you can rotate it. Technically, if you rotate the part and then test in different rotations, it might work. But I don't think it's as good as a full 3D system, obviously. Also, where's their thermal chambers? Where's their thermal chambers?
This is where we shake the satellite in all different directions every axis and then into every different frequency, amplitude, etc. I think before us, it's been 4 years for any previous startup to go from day one founding to having something on orbit. 15 months we went from founding to having the satellite designed, built, ready, and tested.
How are you able to do that so quickly?
This is where I give credit to my co-founders. All of the compute module and antennas and everything else they built in-house by hand. We were working through the night up until the day that we...
Wait, why would they build it in-house? Couldn't they? There's working modules already. Are they like building it really in-house? Like they can just use an existing system that works. But okay, yeah, we're reacting to some inside the startup launching AI data centers in space. That's what we're doing right now. Yeah, welcome.
Ship down the payload. So the first satellite is a small sat. It's about 60 kilograms, the size of a small fridge. And on that, we have been responsible for the compute module and the antennas. We've contracted one of the bus manufacturers, a company called Astro Digital, to build the bus. And so, yeah.
Oh, okay. So they've contracted out some work and they're public about it. That's nice.
Yeah, there's the high-powered GPUs. That's the H100 that we've got from NVIDIA on there. There's a bunch of different antennas that we're testing and using on that one.
All of this led up to the historic launch on November 2nd.
Okay.
Good evening and welcome to SpaceX's live coverage of our 4th bandwagon rideshare mission. On board are Starcloud's
And these guys had a rideshare. It's, if you didn't know, every once in a while, SpaceX opens up a rideshare rocket where the poors, the common people who can't afford the entire rocket, basically get an Uber pool share ride to like put all their parts together and then deploy them into space. It's actually quite a hard process to get approved to do the rideshare because they have to be confident that whatever you're building won't explode and destroy everything else in the rideshare. So there's like a whole approval process you go through. Usually it's quite stringent. I think it's cost feasible. I think it's not millions of dollars. It's definitely like tens of thousands, probably around 100 to 200K for a launch like this, maybe like 2 to 300K. I don't know what the rates are, but it's like much more feasible than obviously getting a whole rocket. Like a whole rocket is millions.
Starcloud 1, which is...
Can we do that? I mean, yeah, we can get a rocket up for 50K, probably 50K, but that's still a lot of money.
It's looking to prove that modern data center hardware can run in orbit, starting with the world's first NVIDIA H100 GPU deployed in space. All systems are go for an on-time liftoff.
Look at all these.
Launch
is this real?
Go for launch.
Is that like actually
3,
when they launched it?
2,
it looks like
1,
a penis. I'm sorry, this looks like a penis.
Go bandwagon, go ADD 425.
I'm ready. Ooh, look at that dick go. It's glowing. Vroom.
Over the next few months, we'll be doing all this whole battery of tests we've got lined up. So training the first model in space, running high-powered inference in space,
all rockets
running a version of Gemini.
That's why I love rockets.
We'll be doing a whole bunch of interesting firsts over the next few months.
Say more about your second launch, which you already have planned. Yeah. What's going to go up there, and how is that going to be different from the first one?
So the second one is launching in October next year. That's going to be at least 10 times more powerful than the first satellite, and that will fly the Blackwell architecture from NVIDIA. It will have a whole bunch more GPUs. So that one will be...
Okay, I think I've got it. I've got it. I see what they're trying to do. You know, honestly, not a bad strat. Honestly, like I get what they're trying here, and I'd say it's like a big if true moment, and they're just trying to scale up to showcase that they can deploy a gigantic satellite. I think they're very far away from it, though. They're like so far away. They're trying to say that they're making good pace, which is fine, but they're still years behind existing satellites. They're not even at the same... Where's their fucking satellite image? Look at this shit. It doesn't even have deployable solar panels. Do you even have solar panels? Do they even have the they don't even have foldable solar panel wings. How are they handling heat dissipation? I don't see it. I don't know. Maybe they have the solar panels here, or like the radiation metal bits somewhere that they haven't attached yet. But like, this is definitely, I can already tell from looking at this is less complex than many satellites that exist today. I'd say most satellites are more complex than this. So we'll see. They have a lot of catch up to do. and then they have a lot more work to do. I mean, they're getting venture funding, so like investors are falling for it, I guess, and paying the bill. So who knows? That might be enough. That might be enough for them. Yeah. Okay. My consensus is I hate it too early. I see what they're trying to do. I think it has potential. It does have potential. I kind of morally disagree with it in that I feel like humanity should be able to figure out our data center and energy problems here on Earth before we resort to sending literal rockets into space. But I get why they're doing what they're doing. Okay, fine.